Hello, this is your backup lesson for, producing evidence 1 for the assessment we are currently doing in Year 9 Science. The very first thing I'm going to do before I even read the question is know that everything I do in this assessment is relating back to the question that I am asking. So I'm going to go up and I'm going to grab that research question: how has continental drift affected the evolution of flora and fauna throughout the world? And I'm going to grab that, I'm going to copy it, and I'm going to bring it back down to where I'm working right at the moment. So I'm going to put it right in there. So now every time I do anything, it's going to be right there with me. And I'll just make this bigger so that I can see more of my screen. And there we go. So, for our evidence 1, the first thing we're going to do is read it. Okay, conduct research to gather scientific evidence to address the research question and evaluate the claim. Okay, so the important thing I see in there is to address the research question. Okay, now yes, evaluate the claim is there as well, but I think for my purposes right now, I'm going to highlight that. Okay, the following graph shows the amount of marine animal diversity as a function of time and continent fragmentation. The graph in the top box shows the level of marine animal diversity as a function of time. The graph in the lower box shows the fragmentation of continents over the same time frame. Okay, same time. Hang on, just the time scale in the same is the same in both graphs. So I'm going to highlight that. I was about to highlight the same time scale or the same time frame, but this means the same thing. So I'm going to highlight that. So we've got the same time scale in this graph at the top as we have in that graph at the bottom. The following graph shows the amount of marine diversity, blah blah. The graph in the top box shows the level of marine diversity, and in the lower box shows the fragmentation of continents. So there is the important things for us to know before we even look at the graph. So at this moment I have not even looked at the graph, but now I know what to look for, or at least I know what I'm looking at. Now there's also some interesting stuff down here that I can't highlight. Straight at the bottom I see I've got 3 different views of the world. And notice what's different about them. Okay, in this view I've got a lot of really strange shapes that I just do not recognize. In this view I've got some shapes that I recognize, but something looks strange about them. And on this shape I've got a lot of shapes that I recognize, but I'm not really, there's something wrong. There's something that's not right. Okay, so down, we'll go back to, first of all, we'll go to this one, Ordovician. Okay, is the way I'm going to pronounce it, Ordovician, and that's a stage or a time, and then Triassic, and then Cretaceous. Now we know Triassic very well from the movie, so that's the time when dinosaurs were around. And what I'd like you to notice is, even though we can recognize Africa, and we can recognize South America, and we can sort of recognize North America and Asia, notice they're all together. They're all like one big continent. And then we've got Cretaceous, which is kind of like our world today, but Africa and America, South America, look a little bit too close together, and North America looks really, really funny. And look at that. What's that? That's actually India, as it's been moving towards Asia. Okay, and then we've got down there, what's that? I think you'll find that one day will turn into Australia. Okay, so now that we've looked at the reading on the top and we've worked out that there are 3 distinct phases here, and there is a difference between this phase and this phase and this phase, we can move on and look at the graph. But before we do, I'd like you just to stop the recording and write down what you see different about this Ordovician stage, about the Triassic stage, and about the Cretaceous stage. What is different that you can see about them before we even begin to look at the graph? Okay. Welcome back. Now, let's look at the graph. Again, there's two graphs, this one here, and then there is this graph here, and there is a similar or the same time scale. So if you look there, the CM there is aligned between both of them. The ORD, now the ORD here and the ORD here is the Ordovician. Okay, so that's the Ordovician stage between there and there. And then we move our way through, and then see how we've got the TR, that is our Triassic stage, and that TR on that graph and this TR on this graph are exactly the same place. And then if we move over to the Cretaceous, I'm not actually seeing anything that stands out as being Cretaceous, but if we look there, see how the orange is, the map itself is orange there, and we've got this orange section here. I'm guessing that those two relate, because if we look back at the other ones, in the Triassic is purple, and in the Ordovician is green and green. So I don't know why the Cretaceous stage is written PG, but I'm guessing that there is our Cretaceous stage. Now let's look at the graph. Actually, I think right now is the time for us to slip along and just look at the video that they've suggested we look at that relates back to these graphs, and then we'll come back and have another look at the graph. So let's slip across to the video that is here. I'll make it full screen, and now let's just listen.
Geoscience.
Okay, before I do that, I'm going to stop here and
here we are looking at a map of the continents in black at the start of complex animal life 541 million years ago, and the locations of marine animal fossils as we move to the present. We begin with the continents dispersed and the predecessors of North America, Europe, and Russia colliding. Eventually, those continents collide with the southern landmass called Gondwana to form the supercontinent Pangaea. At the same time, marine animal diversity falls to its minimum, as seen in the black line at the bottom.
Okay, now notice that is an important point that he has just made. The marine diversity, see all the little dots that we're seeing there? Okay, now that's the marine diversity across the world at the time of Pangaea, and at that time, down the bottom here, and I'm having trouble getting it without getting the line up, that line massively drops. Now that's our marine diversity section of the map that we're watching as we watch the world change in front of us, and it's just dropped all the way down like that. And let's continue the video.
Afterwards, Pangaea breaks up into today's continents, most dramatically represented by the collision of India with Asia, and marine animal diversity reaches its apex. I'm Andrew Zaffos at UW-Madison Geoscience.
Okay, so there we have it. Again, our marine diversity when India collided with Asia, that was when we had the most, just before is when we had the most marine diversity. So that's interesting to know, and now we can go back and have another look at our graphs. If I can find it. There it is there. Right, so again, we have our marine diversity. Now that's the graph that we just followed along there, and you can see at this point in time there was no marine diversity, and there was no marine diversity because there was no life on Earth back in that area there. And then life happened, and it started getting bigger and bigger and bigger up until this point, and then there was a bit of a drop, and then it came back up again. And so there's a lot of different marine mammals or marine animals in this phase of the life or the world, and then it drops down a little bit, and then it comes back up again to that same level, and then it drops down to a really small amount. When you look at it, that's a really small number of marine animals or marine diversity compared to everything before it. Almost compared to when there was no animals on the Earth at all. So there we drop right down to there, and what I want you to do is just notice as we move down what part of the cycle we're in. Okay, and then it starts to climb again, and it climbs higher and higher and higher until that point that he spoke about in the video, which is right there, which is when India collided with Asia and started forming the Himalayan mountains. So that's what this one is showing. That's showing basically how many animals are in, animals and plants are in the ocean over a stretch of something like, I think it's 500 million years, and how and this one down here is showing how well, it's called the fragmentation of continents, which basically to me means how many different continents are, and how much the world has changed as it's travelled through. So we've got this fragmentation, and the world's pretty much fragmented like it is now in this one here, and this one here you've got as many, almost as well, actually you've got more in this one here in the Cretaceous. That's interesting when you look at it. The Cretaceous stage has more continental fragments or more continents in the Cretaceous stage than it does now. And then if we look at the Triassic stage, have a look at how many continents there are. Now don't look at the lines between the continents, look at the big purple landmass and notice how many are there. Okay, so so that's our graphs. So now that we have all of that information, let's move on and answer a few of the questions. So, what are the questions? Identify the trends, patterns, or relationships of the evidence. So this is important. What's happened here is that's really the question. Identify the trends, patterns, relationships of the evidence. But what we've got is some help, and that is the question that the two questions that's inside. The first being is what's happening. So, and in this case, what's happening in each of the Ordovician, Triassic and Cretaceous periods. So what I've done straight away is I've put down Ordovician, Triassic and Cretaceous, and then the next question is what are the overall trends. So I'm going to go back up to here, and what I've done is I've got this, which I've, if I can move it, which I'm overlaying, and there's our first area, the Ordovician, and I've taken that, and that's the period that they're asking about, and the question is what is happening. We've got two graphs. Graph number one, marine animal diversity. What is happening with the marine animal diversity? And the next question is what is happening with the fragmentation of the continent. So here in this little section, which is the Ordovician and a little bit either side, what's going on? And you can see that what we've got on this graph is it's moved upwards, and after that stage it starts to move downwards again, but that's moving up. So the fragmentation of the continents, and this one here is showing the graph moving upwards as well. That's in the Ordovician. So what I'd like you to do now is press stop on the video and write down what you believe is happening in the Ordovician period. Okay, thanks for coming back. I look at that and I say to myself, we have a fragmentation that is growing and we have marine diversity that is growing. So I'm not going to write a full sentence here. I'm just going to write down that both are growing in the Ordovicious period. Now, I'm going to copy that, Control C, Control V. I'm going to change its color. We'll move it across to the Triassic period. Format auto shape, change color to a purple. Yes, purple's the color that we want, and press OK. So now you can see during the Triassic period what has happened there. So straight away, that point we were looking at in the marine diversity has happened right at the beginning of the Triassic period, and really when you look at it, just about everywhere on both sides of the graph is higher than what it is in the Triassic period. So this one here, this graph is of the marine animal diversity, and it is there, and this graph is of the fragmentation, and it is there. So what I'd like you to do is take a notice of what they are and go back over here and stop the video and write down for yourself what is happening during the Triassic period. Okay, welcome back. So in this section, both graphs, and I'm going to put both graphs, are reducing. Okay, and again, I'm doing that for time-wise for the video. What I'd like you to write down there is what you see happening. I'm just seeing that both graphs, but you would actually name what each of those graphs are to be able to do it properly. Next, we're going to look at the Cretaceous period, and I'm going to copy again. Oh, I've put that way down there. Let's Control Z that and Control Z that, and we'll click up here, and I'm going to copy this again, and I'm going to now move it over to this section and cover the area that is the Cretaceous period, which is right there. And just for my sake, I'm going to change our color to orange. There's an orange there, and OK. So the Cretaceous period is now there, and you can see I've gone a little bit either side of the Cretaceous period because there's our orange section there. But have a look at what's happening to the graph. There we have at the beginning of the Cretaceous period a really big number when it comes to the fragmentation of continents. Okay, remembering if we went in really close to it that India was its own continent at the beginning of the Cretaceous period, and then marine animal diversity at the beginning of the Cretaceous period right through to the end of the Cretaceous period. What's happening there? So now we'll go back down to our question, and I'll ask you to stop the video again and write down what you see as is happening in these graphs during the Cretaceous period. Stopping that video now, and welcome back. And again, what I see there is that both graphs are growing. Now, I'm not sure what's happened there, but it's gone white, so I'll see if I can change the color of the text. Both graphs are growing. We are seeing there. Again, I've done this very quickly for the sake of the video. I would expect you to put a bit more information there. Okay, now what are the overall trends? And the overall trends, well, let's go up and have a look. So what trend have we got here? Okay, if we look at the fragmentation of continents, we've gone from a lot of fragmentation to very little or no fragmentation, back to a lot of fragmentation. So that's what's shown in the graph. We also have, in our marine animal diversity, we have pretty much a standard line through the middle, I'm thinking. An average. If we were to take the average of that marine diversity, I would think it would be a line that's running roughly through there. Okay, so we've always got marine diversity. It just ranges as to from up and below, from above and below the average marine diversity is what I'm seeing. We've always got fragmentation, but I don't know if there's as much of an average here, but it seems that, well, we don't know what happened before this, do we? We really don't know what happened before, and we don't know what's happened after, but we can guess. But what's happening? It's just always moving, isn't it? So there's my second thought, is a trend is that the Earth's crust is always moving. The marine and animal diversity is always changing, but seems to have an average, and then when you look at it, the trends seem to move together. And they're the three that I'm going to pick out for you, and that is the continents, or the crust is always moving. We always have marine animal diversity, and there seems to be some sort of an average. Now this is the absolute minimum that you would need to write down in here, and I'll just zip them in. Marine crust is always moving. Marine diversity is moving up and down, and there seems to be a relationship. Okay, and again I'll go back and point out that relationship. If you look at the graph, it goes up, and then it comes down, and then it goes up, and then it comes down, and then it goes up. With the marine animal diversity, with the fragmentation, it goes up and down, and then up and down, following a similar path. That there is a little bit out, but we can see that they came back together. Okay, so that started to grow up when that happened there as well. So I'm thinking we're seeing some sort of a similarity between the two graphs. And they're the three primary things I'm going to show you. And I think there are other things that you would be able to add to the overall trends.